Hello everyone, my name is Elise White and this is my final presentation for RMS 6280. I will be exploring automated feature extraction as applied to a particular flood event, the Souris River flood that occurred in Minot, North Dakota in 2011. I decided to focus my project on a flood event because of my affinity for remote sensing applications to disaster management. I wanted to explore how effective AFE would be as opposed to a heads-up digitizing for extracting the flood extent, as this can also be explored in many other disaster response efforts. In my project, I apply feature analysis to extract the flood extent of the Souris River flood event that occurred in 2011 in Minot, North Dakota. The river length of the assessment area is 27 miles, and my plan is to extract that river feature as well as the inundation level surrounding that feature. All the data used in this project was freely available. I exported a false color image from the National Agriculture Imagery Program, and this provided an image of the river for the feature to be extracted. I downloaded Landsat 7 enhanced thematic mapper imagery that showed inundation levels from the USGS's Earth Explorer website. The GOI and LiDAR data were acquired from the North Dakota government site that provides a mapping service for GIS and other related data. The data was then projected into the WGS UTM Zone 14 North coordinate system, all except for the LiDAR data, which resulted in some issues that I encountered. This image provides a general overview of the workflow for this project. The data sets were brought into ENVI for atmospheric correction and subsetting, and then transferred to ArcGIS for feature extraction. They were cleaned using ET-GeoWizards and ArcGIS tools, and the metrics were then derived from these results. A map was created to show the inundation extent as well as the original river feature. The Landsat image, I masked out the clouds in red and the gaps in yellow as to not confuse the learner. The training sites were then created as seen below. The gaps that resulted from the mask layers were cleaned using ET-GeoWizards and then dissolved using ArcGIS dissolve tool to create the final inundation extent. This GOI image was more recently acquired for the project as I stumbled across it a couple of days ago. It provides 0.5 meter spatial resolution, so the extraction provided more detail of the inundated areas. I also noticed that there was less misclassification with this without having to mask as I did with the Landsat 7 image, and it's probably due to the spatial resolution that it was able to distinguish the features more clearly. Here is the final inundation area shown for the GOI image. You'll notice that the features, the inundation actually outlines those buildings and vegetation that are not covered by water, and I find that it gives a more definitive idea of the level of inundation occurred and those areas affected. This is the NAIP dataset that was extracted from the image service. I created a false color composite using the infrared band, and it highlights the water clearly and the river extent very clearly. I created training sites that bordered the boundaries of the river extent so that it could be more clearly defined. My original plan for this project was to not only extract the inundation extent, but to also incorporate LiDAR analysis and extract the buildings. My goal was to overlay these two layers and identify those buildings by using the Select by Location tool in ArcGIS to determine all those buildings within Minot that were directly affected by the flood. This was unsuccessful due to alignment issues. I was unable to apply the North Dakota State Plane coordinate system directly to the LiDAR point cloud. I had assumed that selecting the next best coordinate system would work as long as I was able to project this data into a different spatial reference. However, none of the methods that I tried seemed to work, and I was unable to get the data to align with all the Landsat, NAIP, and GOI imagery and resultant layers. So therefore, the buildings that were impacted could not be identified. The final product was a map of the inundation occurred in my study area. This is the map on the bottom, and as you can see, I have it compared to a previous map that I created using heads-up digitizing. Simply using heads-up digitizing, I incorrectly digitized some features, assuming that they were a part of the river, when in actuality they were deviations from the river. And this is the actual river extent as extracted using feature analysis. This map at the top took me roughly 2 hours to digitize both the river and the inundation area and create the map, whereas it took me approximately 30 minutes, if not less, to create my final map using automated feature extraction. The result was 2,600 acres approximately of inundation for this particular area of the Souris River flood event. I found the project to be very successful. Ground truthing would have been very effective in testing for levels of accuracy, although I was able to create a classification image in ENVI and compare visually the results that were extracted for water to my layer extracted with feature analysis. It was a relative comparison, but close enough to allow for a general extent to be determined. AFE is more effective, particularly feature analysis with high spatial resolution, and if that data is multispectral. I would like to see this further applied to other applications of disaster management, and I think that it would be very effective. Thank you very much, and my contact is below.